Hello everyone, welcome back to the sessions of DBMS, Database Management Systems. It was been the day we have finished with the DBMS in the last Saturday, and we have done with the basic importance of DBMS, and we have seen a few important factors of DBMS. Alright, so now let me quickly revise what we have done in the last session of DBMS. In the last session of DBMS, we have learned the very important things about the data models of DBMS, and along with that we have learned about what is SQL basically do and what are the different languages are presented in SQL and how it will be get used in the application development. So, let me quickly get through the what is SQL is. SQL stands for Structured Query Language, which is used to communicate between a database as well as end developer. So, now what will happen is SQL is a terminology which is very well known factor for your databases, like we have a databases like Microsoft SQL Server, Oracle and MySQL. Like that we have a number of databases in the market, and every database uses a language called SQL, and this SQL again segregated as different languages, such as the first language we usually call it as DDL, stands for Data Definition Language, consists of a few queries like create, alter, drop and truncate. These are the 4 queries comes under DDL. Where it is comes to DML, stands for Data Manipulation Language, consists of insert, update and delete. And the next language called DQL stands for Data Retrieval Language or DRL. Anything is same, DQL or DRL, Data Retrieval Language or Data Querying Language, which is consist of a query called select. And the next one is TCL, stands for Transact or Transaction Control Language, consists of 2 queries, that is commit and rollback. And the last one is DCL, stands for Data Control Language. We have something called grant and revoke, right. So, now let me show you with a simple thing. Okay, I will just write with a simple notepad and I will let you know how this will be used in your databases. Okay. So, the first language is SQL, have a number of languages, that is DDL, Data Definition Language. Right. So, we have a language is called create, right. The next one is something say alter, next one is drop and the next one is truncate. Please list it down all these queries if it is possible. Okay. Data manipulation language, that is insert, update and delete, right. And the next one is sometimes you can call it as DRL or sometimes you can call it as DQL, Data Retrieval Language or Data Querying Language. Right. We have only one query here, that is select statement. Alright. Next one is a TCL, Transaction Control Language. We have 2 things here, one is a rollback followed by commit, and the last one is DCL, Data Control Language. We have 2 things here, again it is something called it as a grant and revoke. So, these are the few queries we have discussed in the last session. But before I am talking about all this query usage, Alright. So, I told you that today's class is depends, or today's class we are talking about entity and relations, very important thing. So, in today's class we our major objective is to learn about entity as well as the relations between an entity. If you are well aware of how to design entity relationship diagram, shortcut we usually call it as ER diagram. If you want to define or if you want to design a database architecture, first you are capable to draw the diagram of your database in terms of ER. If you are able to draw this, then after drawing this diagram, after that I will include an SQL language between a database, and this SQL language I will utilize this any of the database which are the listed here. I can use a database product called Oracle, or I can use a product called Microsoft SQL Server. Alright, or else I can use open source as MySQL. Alright. So, now after that, whatever I am going to use here in this particular thing, and I will let you know how to install this on the machines. Okay. So, please try to follow the same instructions when you install that into your machines also. Okay. So, that is the reason today our main objective is to learn what is an entity and what are the relationships between entity, and at the end of our session we will try to draw a diagram for ER application, and I will give you one assignment for you to draw an application objective for ER, that is creating a module to draw the ER application. Now, let me start with a simple presentation. This is the day 4 of your DBMS. In this, the main objective is to learn about the today's session is, first one is entity sets, second one is relationship sets, design issues, mapping constraints, keys, ER diagram, extended features of ER, and the designing of ER schema and reduction of ER schema to table format. Mean to say that what I want to talk about in today's session is, I just want to talk about how to build ER diagram, and after building the ER diagram, how do you map this ER diagram to create the table in your database. Am I very clear what I am trying to tell you in this session is? I am repeating again, I am trying to draw a ER diagram first, right. Once the ER diagram has been drawn, then I will try to sequentiate this ER diagram with a tabular format in your application. So that what I mean to say that ER diagram can be considered as a tabular format. For that, to complete that task, we have to know about what is an entity set, what is a relation set, and how do you design that, and how to map the constraint, and how to design the ER diagram. These are the few basic constraints we need to know. Please try to list out this all the things what you need to learn in the today's session is. One is entity sets, relations, design issues, mapping constraints, keys, ER diagram, extended version of ER diagram, and ER diagram schemas. Alright. So, now let me start with the first point about entity sets, right. So, what is the entity set? How does this entity set will be utilized for this? The first one is database model as the collection of entities, first thing, and relationship among that entities. Okay. Now, you may get a doubt that what is an entity here. The next immediate point I have written there, that is something called an entity is an object that exists or distinguished from the other objects. Very important factor I want to talk about, that is entity. Entity is nothing but anything is an entity in this particular world, yes or no? As a person is an entity, as a particular tool is an entity, a particular laptop is an entity, a particular desktop is an entity, a particular TV is an entity. Everything in this world is an entity, and every entity have a specific features, right. For example, I do have a mobile device. My mobile device can be a form of another mobile device, but still I can have my mobile device with a particular things, nothing but I do get my own mobile number, and I'll also get same number which is not exist for any other mobile devices, nothing but you can call IMEI number, right. So that number is a basic number which is not exists for any other devices, only one my device can be exist for this, alright. So that's the reason entity in database, entity in database. Anything is entity. Okay, I was talking about in the last class, I was been into that there are different objects in every databases. Yes or no? Right? See that if I have a database server, in database server we have a number of databases, and every database consists of some set of objects. Now let me list it out again. What are the list of objects we have in databases? Okay, database object. Every database have these objects here. So what is a database? First thing, the first object we usually call it as a tabular format. Second one is a view. Third one is a synonym. Fourth one, it's something say procedure. Fifth one, alright, a function. Sixth one, triggers. Seventh one, constraints, right. Next one, it's something like relations, relationship among the different objects, right. For example, as every DBMS product or every DBMS in the sense it's a system software, right, it's a system software. So what are the system softwares we have here? We have system softwares like, take an example as Oracle, right. What is Oracle database will tells you that the data of entire database, data of any application need to store in tabular format or tabular format. Otherwise, you can just say that simple say a table format. Alright. So what is a tabular format will tell you either the data will be consist of a column and rows, right. Means what? You may get a doubt that here you are listing out a number of objects here, but as you are telling the data is storing in only one object. What about the remaining objects? Yes, we have a particular thing to be remembered on this. All these objects, whatever it listed out here, that these all objects provide you the security which is presents the data in a tabular format. Am I very clear? Repeating the sentence again, please try to note it down. So the data of any database or data of any application will be stored in tabular formats. Nothing to say that it's simple as that table. So, but there are the different objects is also presented in your databases. But what is the importance of this databases concept is make sure that you want to provide a security to the data which is presented in your database table, and the remaining objects will helpful for that. Okay. So now let me consider only these parts. Okay. So now I'm not gonna use this. Okay. Now let me have up to this only. Right. So what is that? Views, synonyms, procedures, functions and the triggers, all this will be used to give the security for the data which is stored in a tabular format. Am I very clear, guys? Yes, that is what I just want to talk about here. In this particular thing, what I want to talk about is an entity which is an object, nothing but any of that, maybe a table, maybe a view, maybe a anything, right. And it has to be exist over in the database, and nothing but you have to create the database into your database first. First you have to create that object into your database, and that object will be unique object in that particular database. For example, if I am giving a name of a table is something say ABC, and in the same database I supposed not to use the same name again. Am I very clear what I am trying to talk about? See that, for example, I have a tables, right. I have a number of tables here. First thing is what I need to do, every table I can call it as an entity. Table ABC is in one entity. I can't use the same ABC table again in the same database. Am I very clear? That's the reason you can just see here, it is a distinct from the other objects, nothing but examples you can see here, a specific person is an example, a company as an example, a event is an example, a plant is an example for entities in your databases. Am I very clear? Alright, clear now? Now let me show you the slide again. Here entities have an attributes. What is that attributes here? Examples are persons have a names as well as the address. Yes or no? Here I can call it as every person is an entity. As I am a person, I can call it as a one entity. And for me, I have a name, I have my own address, right? So that is an attribute. It's pretty simple, I can tell you. Attributes are pretty simple, I can tell you. For example, as soon as if you woke up from the bed, will you directly go to college with the same way? No, 100% not. Because of what? As you want to become more attractive. If you want to, entity has to be looks more attractive, we need to add an attributes to it. Attributes are something which need to make up, or else have a iron dress, shoes, wearing a watch, right, wearing a new colored shirts and all. That everything is comes under defining your object to looks more beautiful or more good, so that we add attributes to it. Same way, every table have an attributes. Attributes can be represented as a columns, vertical lines of any table. We basically call it as an attributes. Okay, see that entities have an attribute, something like people have a names as well as the address. Now let me come to the conclusion. What is an entity set? Entity set is a set of entities of a same type to share the different of same properties. Alright, see that examples are set of persons, set of companies, set of trees and set of holidays. Mean to say that if you group all the persons at one particular place, you can call it as that is an entity set. Same way, if you look after a databases, if you group all the tables at one particular place, that I can call it as an entity set, where it consists of a number of entities at one particular place. Very simple. Yes? Alright. So now from this particular slide, what you need to learn is, you need to learn about what is a database model is. It's a collection of entities and relationship of those entities. An entity is basically a unique and that has to be exist at one particular place. Entities have different attributes, something like having a persons with a different names and addresses, and followed by entity set. Entity set is something which having a group of entities has to be gathered at one place. A group of persons at one place, a group of plants, a group of holidays, a group of companies has to be at one particular place. If I am sequentiating the same concept to a database, what will happen is all the tables will be stored at one particular place, that we can call it as entity set. All the views will be stored at one particular place, that I can call it as view set. Right? All the procedures will be stored at one particular place, that I can call it as entities of procedure set. That's the basic thing is. Alright. So that is what you need to learn on this particular thing. Right. Let's see that entity sets of customer and the loan. Right. See that I have a customer ID, customer name, customer street and customer city, followed by two more columns here, a loan number as well as amount. Yes, this is very simple. These are the two tables here. The first table is a customer table and second table is loan table. Yes or no? Am I very clear? Right now I am talking about the table set. All these tables has been grouped at one place, right? You can see that here loan table and followed by customer table has been embedded into one block line. You can just see that black line, the outer line. So this one will suggest you that it is something which has been embedded at one particular place or it integrated at one particular place, and that I can call it as something like entity sets. Yes, now this entity sets belongs to a tabular format. Yes, like this we have entity sets for views, we have entity sets for procedures, we have entity sets for functions, or we have entity set for triggers also. That will becomes practically as soon as when we completed this ER diagram. Right. Now let me talk about the second one is an attributes. That's now I am given you a simple example, right? The simple example is to want to make yourself is good, you add a new features to your simple entity. Yes or no? For example, it's pretty simple, I can tell you. For example, I want to looks my mobile more beautiful or more good, or everyone has to attract to a mobile. What I'll do basically, I'll do have my mobile with I can go for a cover, right? I can go for a screen guard. I can have some different activities. I'm going to add it to my mobile. Yes or no? So nothing what will happen is my mobile looks more beautiful than the other person mobile, or it looks more better than the other person mobile. So what will happen here, we have added a few more properties to your application or a few more properties to your attribute of a simple entity set. Same way, if you want to add entity sets, if you want to add attributes to it, what is that? Attributes are something which an entity is represented by set of attributes, that is descriptive properties is processed by all the members of an entity set. Please try to note down this very important factor, very important. If possible try to note down this important point here. An entity is represented by a set of attributes, that is a descriptive properties is processed by all the members of an entity set. In previous example, we have given a customer, right, in which customer ID, customer name, customer street, customer city, loan and loan amount. Yes, there are the two sets we have here. Okay, the one set we can call it as a customer, the other set we usually call it as a loan, right. So now what is actually the thing is, the customer is an entity and followed by customer ID, customer name and customer street and customer city, all this comes under an attributes. Loan is entity and followed by loan number as well as amount is comes under entities. Yes, am I very clear? I am just tell you what is that in this. Okay, now please see that, right. So first one is customer. Your customer here, the customer is something which, right, here your customer is the entity name followed by all ID, name, street and city. All this comes under entities attributes, right, which will be for another table called loan, consists of loan number as well as loan amount. This is comes under the attributes of loan tables. Yes, pretty simple. In simple word I can tell you, in simple words I can tell you what is this entity and what is an attribute is. And just take a simple example as a table, right. Your table is an example for entity in which whatever the vertical lines which is able to shown there, that all comes under attributes there. Am I very clear? Yes, that is what the simple thing is, right. But you can just see here domain, a set of permitted values for each attribute. Yes, what is this domain is? And before you talking about domain, let me talk about, for example, I have a customer ID attribute in a customer entity in which ID is always an integral format, right. I need to enter only IDs into that. Yes or no? If I am trying to enter something as a string value into it, it's supposed to be not permitted. Yes or no? That is something called it as a domain. Before you talking about domain, you need to know about what is this attribute type is, so that you will understand if the type is integer, a user well known about it that he can able to enter only integral format, number format. If it is a string, nothing but name is a string, right, he will only enter his names, not enter any digit format. So that before you talking about a domain, you need to know about what is the type of attribute which is defined by the database designer on the application. Yes, see that attribute types: simple and composite attributes, single valued and multi-valued attributes, right. Multi-value attributes are phone and numbers. Derived attributes, it is something like can be computed from the other attributes, like for example age, given the date of birth, which comes under the derived things. Okay. As we are talking about a person is an entity in which we have a derived data type called age and given the date of birth, that everything is comes under the process of the derived data type. Okay, we will talk about in detail here. Okay. So, what are the different type of attributes we are? We have attributes like simple attribute, we have an attribute like single value attribute as well as multi-valued attributes, and followed by derived. Single valued in the sense the value which has to be only one, alright. So, whereas multi-valued in the sense phone as well as number, mobile numbers. Okay, in one device we can have multiple numbers, right? That is something called multi-values. You have a icon called contacts, right, in your mobile device. In that contacts, how can you store? You can also store one, you can also store more than one. Now that is comes under multi-value, nothing but as some of your database developer has been developed multi-valued attribute concept on the application of contacts. Yes or no? Alright. Now let me go to the next one, derived. Derived in the sense which for example every person we are calling as an entity, right, and every person has some attributes like name, address, right, all these things comes under the, and if you go for again extension version, like for example every person have a name, but we need to know what is the age of that person and when he is born, and right now what is the age of that person, and I need to know what is the mobile number of that person, and what I want to know is I want to know email ID of that particular number. Nothing but again first you have an entity, this entity have a number of attributes. Let me take one attribute called person name, and here this person name again go to the next levels, nothing but level of age, date of birth, his email ID, mobile number. This all comes under derived data types, or I can call it as derived attributes of a particular table list. These are the things will be utilized whenever you defining entities of your application development. Am I very clear now? Right. What we need to learn from the previous current slide is we need to learn about what is an attribute and what are the different types of attributes we have. We have an attributes called simple attribute, and we also have an attribute called single as well as multi, and followed by we have a last one, call it as derived data types or derived attributes. Now let me talk about composite attributes. See that this is what I want to talk about in the previous part. Let us see that. Right. First one is composite attributes as well as composite attributes. Anything is okay. See that name as well as address. These are the two basic attributes of a specific table or specific entity, in which you have a first name, middle name and the last name. And the other entity, same entity, we have another attribute called address, right. In address I just given only street over there, and again if you street can again consist of a number of values like street number, street name as well as specific apartment number. Yes or no? For example, if a courier comes to your address, right, he will comes to your street and again he will search for where is exactly your location is, right. How a courier boy knows that the location and the particular address? You have specified that you have address column. In that address column you have specified the again a few important factors over there. The important factors like you have to be in this particular street. Yes, I was been in that street, but I need to know in that street which person I have to deliver my product is. I can deliver to the product with that particular street name and the door number as well as the particular street, apartment number. If I see all those things directly as a courier buy, I can directly reach over there. Nothing but you can see that you have Amazon website, you have a Flipkart website, you have some other websites, e-commerce websites, in which you are giving all these details, right? Indirectly or directly, what I want to tell you is, some of a database designer has used derive attributes concept over there. Instead of, he also used single, he also used multi, and here he has used derived also, so that his works is very simple and he can also give information to other person with this derived attribute also. Am I very clear? Alright. Now let me go to the next one, is relationships. Relationships, I was explaining you in the last class, right? I was explaining you the relationships, a basic simple thing I was explaining you, that for example you have two tables. The table one is an employee table and the second table is a department table, yes or no, in which I was explaining you every employee belongs to a particular department, like development, testing, administration or some other. So we have given an ID to a particular employee so that he can able to search in the department table. So that whenever you want to get the data from both tables, you need to merge it and you need to get it. How do you do it? It's pretty simple, with the help of relation sets. Now let me talk about here with the relation sets here. Relationship is an association among the several entities. Not only single, it could be several entities, nothing but not only single table, it can be of multiple tables. See that I have here the three tables here. One is table 1, depositor table number 2, and the third one is A102. I want to get the data of these two. Then what I need to use? I need to use a terminology called relationship set, right? So relationship set is a mathematical relation among n is greater than or equals to two entities, nothing but the value, the entities has to be greater than 2. If you want to make a relationship between a single table among the same table, it is not possible. Make sure that your relation set has to be done on the two or more than two tables. Yes or no? Because if I have only two tables, three tables, 4 tables, then only I can get the data. Yes or no? But I can't get the data from a single table. Where is the use of relationships here? If I have only one table, that's the reason. Whenever you want to make a relation sets between a multiple entities, and the entities count always supposed to be greater than or equals to 2, and in that greater than or equals to 2, there is a particular attribute should be same in the both entities. Let me talk about here. See that each entity set. See that here this is one entity set followed by this is another entity set. Okay, you can just look after here so that you will understand where is exactly the concept is. See that you have a concept here, that is something, say E1, E2 and En is followed by E1, E2 and En. Alright, so that will be an entity which will be represented from the first table to second table, right. So these are E1, E2 and E3, or something call it as relationship, right. So what is I want to conclude from this particular slide is, right, I just want to conclude is what is the relation sets. Relation set is something which getting the data or getting the information from more than single entities. So whenever you perform a relation set between an entities, it's supposed to be n value, in the sense entity value, it's supposed to be greater than or equals to 2. Yes, right. Now let me go to the next one. It's entity relationship. It's a simple relation set diagram for the representation of your relation as well as previously we are talking about entities, right. Customer is an entity and loan is another entity, in which I am just sequentiating. Just see that the second row of a first entity, I am sequentiating to the another one, right. And here this is the row which is again introduced to another particular table, right. So, here this 2 will be gives you the relation set borrows, I mean to say the application, right. Right. Now, let me talk about in detail here relationship set. An attribute can also be property of a relation set. Very important factor. Please note it down that an attribute can also be a property of relation set. For instance, a depositor relationship is sets between an entity sets of customer as well as accounts may have attribute to access the date. Yes or no? For example, imagine that there are the 2 entities we have here. Entity 1 is customer, entity 2 is account. Two entities. Just indirectly imagine that there are the 2 tables, customer table and account table, in which I have to pay the money towards my loan amount on or before 12th September 2017. So, what I need to do is I need to give a specific date to that person, right. I guess you everyone, some people will use a credit cards, right. So, how does credit card bill will be generated? Bill will be generated so and so date and they will give a due date to it. Yes or no? Nothing but the customer has to be pay that amount on or before the due date. Yes or no? If he pays that on or before the due date, he does not have any charges after that. Nothing but there is simple mathematics are involved in this. Yes or no? Means what? On a date format, we have get the some date here. If the date is crossed, we will pay the interest to it. Yes or no? That is what your best example of relationship set. Nothing but I do have my own customer account and followed by accounts, right, which will be maintained by bank. In that I do set particular date, that date is a due date. If a customer pays the amount on or before the date, I don't have any penalties, I don't have any charges. If I have a particular person is not paying on or before a particular date, then 100% I do take a penalty as well as the interest, both. Yes or no? That is what the simple relationship between customer table and an account table. Yes, that is what I want to show you in this example, right. Please, if possible, try to draw this diagram about the relationship sets. Yes, done. Okay. Now, let me go to the next part. What is actually it is? So, what we need to learn in this part is degree of a relationship set, right. So, what is this will tell you here is refers to a number of entity sets that particularly or participate in a relation set, right. Next, relationship sets that involves 2 entity sets as a binary, very important thing, I will talk about this, right, or a degree of 2, right. Generally, most relation sets database systems are as binary, mostly, okay, I am talking about it. Relationship sets may involve more than single entity, such as a simple example I have given here. If relationship between more than 2 entities that are very rare and the relationships are not binary, that would be non-binary, right. So, what actually I want to tell you in this particular slide is, for example, my relation set is on only 2 entities x and y, then I can call it as the degree of this relationship set is 2 in generally, because I am basically entity of a 2, so that I can call it as 2. So, that this 2 we basically call it as binary set. we usually give a name to, in database terminology, we usually give a name as binary table or binary relation. If there is a relationship between not only two, it is more than two. If I say more than two, then I can call it as non-binary relationship. That is very rare cases people will utilize this, right? Mostly the people will use this binary relationship mostly because they are trying to segregate the data only on two tables at a time, not more than. If sometime there are chances here, there are some chances we can also get the data from more than 4 entities at a time, that we basically call it as non-binary. But in generally, when the people are developing that application, mostly they use it as binary. What is I mean to say is, you have a table called employee, you have a table called department. If you are making a relation of these two tables, then I can call it as the degree of this two relationship set is binary, nothing but 2. Yes? Alright. So, where it is something, call it as mapping the coordinates, very important factor, very important factor. How do you mapping the attributes of parts will be very important. Express the number of entities which is another entity can be associated via relationship set. Mean to say that, for example, I want to make one table to be mapped with another table, nothing but another entity, that everything is via on relationship concept. Most useful describing, that is just now I talking about, that is something called it as binary relationship set, which consists of one to one, one to many, many to one and many to many. Please, if possible, note down all these 4 important factors, 4 important things, that is mapping the coordinates. Mapping the coordinates is just based on the terminology of relationships, and this will be mostly on binary, and there are 4 different binary relationships we have, that is one to one, one to many, many to one and many to many. Please copy it. Alright. So, once you done with this, then we basically see the simple examples of one to one and one to many. See that if I say this one to one, every student belongs to only one college, that is one to one relationship. Every employee right now belongs to only one thing, that is something called it as one to one relationship. Right. For example, in a college, one student belongs to 6 different subjects, nothing but one to many. Yes or no? For example, I am a student of a particular class, I can also listen maths, science, social, English, Telugu or some English, the different languages, nothing but what, I am a single person who is interacting with 6 parts at a time, nothing but one to many. But one to one in the sense, I am a student belongs to so and so X college, nothing but one to one relationship. What one to many, one person is interacting with 6 subjects at a time, that is something called one to many relationship, right. Next one is many to one relationship, right. So, for example, pretty simple, let us see that customer, number of customers followed by number of due dates. Yes or no? For example, this we can call it as a many to many relationships. Okay. See that can make and access the date attributes account instead of relationship attribute if the account have any one customer, that is relation from one customer account or account to customer is many to one, or equally customer to account is many to one to many, simple as that. That is what just now I am just talking about. Instead of taking an example of bank, I am just taking an example as a student, both are same. But many to many, nothing but number of students or belongs to number of subjects, nothing but many to many relationship, right? Many to one. All number of candidates, number of students belongs to one college. That is many to one relationship. There are 4 parts you need to remember. One is one to many to one to many, and many to many. 4 different things you need to remember in this particular examples. Okay. So this example or this particular theoretical part will be useful for the next when you start writing a database programming is. Right. At that time you need to recall this theoretical part, how this theoretical part will be uses for your next level. Yes, right. Now this is a pretty simple ER diagram, right, pretty simple ER diagram which tells you about a customer, and rectangle will be a customer and followed by one more thing. See that there are the 2 things which has been shown in rectangular format. If you just observe carefully in this particular diagram, there are the 2 things which will be very simple here. One is a customer and the other one is loan. Both are in rectangle, right? Rectangles represents entities, pretty simple. A diamond symbol between 2 entities which represents a relation, and lines represent the relationship between attributes. Something has been represented in ellipse signs. You have seen, you can just see that ellipse signs, right? All these ellipse signs or something, call it as attributes. If something is double, that is represents multi-valued. If it is dashed, a single, or you can also call it as derived. Underline indicates that the primary key attributes, right? I do not have any underline sign here. There are a few things will be underlined here. See that customer ID is underlined as well as loan number is also underlined. If this 2 will represents you the ID column, primary key column of a table. You may get a doubt, what is this primary key? You have to wait for the tomorrow's session about when we talk about a primary key concept, right? There is a concept called primary key. This will be what I can call it as, there is a concept called integrity. The solution for integrity we can call it as primary key, and all these things that you have to wait for tomorrow's session to discuss about on the theoretical part of primary keys. Right. Please observe carefully the diagram again. Here customer and loan is both or has been shown in the rectangular format, and this will be entities, and the diamond symbol between the 2 entities is something we can call it as a relationship, and followed by the ellipse signs which has been written, that is something called attributes. This attributes again of different types, that is multi-valued attributes and single dash attributes, and the underline symbol suggests you for primary key. Please try to write all these points, very important points. So as you have to design a ER diagram for simple banking application. I have shown you here banking application, right? Let me take for your assignment is you have to create a ER diagram for let us say hospital management system. Take simple example as hospital management system and try to identify what are the entities of the hospital management system and what are the relationships over there and what are the attributes for each and every entities, right? That is what your for tomorrow's assignment. And this assignment today I have done with the ER diagram, right? And this ER diagram I will convert as a tabular format in the next session, because today the time is run out from our 10. So that what I am trying to conclude the session here. The session what we have learned today is we have learned about ER diagrams, right? So in which we have included entity sets, so relation sets and attributes and all. That is what we have learned in today's session. Please you guys try to read all these important points every day, and from tomorrow there is no much theoretical part, it is everything about the practically. I am going to show you practical information on each and everything what I am going to show you on the theoretical part, right? Thank you so much for listening to us. Have a great day. By the way, I am Anil Kumar, which takes you the sessions for the next DBMS.